Welcome to the product 1076 monitoring for SAP workload session. My name is Gerion Fay. I'm a manager in the SAP solution engineering, and I bring with me Bernd and Thomas. Bernd.
Thank you, Gerion. My name is Bernd Schubert. I'm sub-solution architect and located in the SAP Linux lab on-site at the SAP campus here in St. Leon Road. And yeah, I'm responsible for the monitoring architecture and the service pack validation, which we do every year. Thomas?
My name is Thomas Schlosser. I'm also a sub-solution architect, and I'm also doing monitoring and some internal support for SAP.
Good, thank you. So, today we talk about monitoring for SAP workloads. Many customers deploy SAP systems such as SAP HANA for their global operations to support mission-critical business functions. This means they need maximized system availability. Accordingly, IT departments are faced with demanding SLAs. Many companies now require 24/7 reliability for their SAP systems. SAP systems are complex, comprised of multiple components and relying on the OS and infrastructure to function reliably. In order to keep such a system running, intimate knowledge about the system itself and the underlying infrastructure is needed. System data monitoring enables proactive problem avoidance. However, to get to actionable insights, the right metrics have to be collected and combined. This session gives you an overview of the monitoring options and shows how to collect and visualize monitoring data relevant for SAP workloads. So, today we will first look at the monitoring architecture, some fundamentals and what we are using. Then we will cover data sources. We will put it all together in a nice demo and show how this is looking like, because showing is better than talking. So let's start with the monitoring architecture. The Grafana ecosystem provides three important building blocks to an end-to-end monitoring solution. On the data collection side, Prometheus is a time series database optimized for systems monitoring with a special querying language, PromQL, which enables you to combine and monitor and retrieve monitoring data. This is a project hosted by the CNCF, just like the other two components we're covering here. So one thing is the metrics, and the other thing is logs, also important to collect. For this, Grafana Loki is here for log aggregation. It's a simple design and a small footprint inspired by Prometheus and has a pluggable, scalable architecture. And then in the center of it all, Grafana, the graphical UI to bring you all the metrics on your screen together with the logs. It's a web-based, API-driven platform which is deeply customizable, so you can create all kinds of dashboards with it. All those components are available with SUSE Manager. Let's look a little bit deeper into the architecture here. So, on the SAP systems, you will have exporters that expose metrics to Prometheus, which queries those exporters in configurable intervals to collect this data. And then on the other side, Grafana Loki receives log information through PROMTAIL, which is also running on the individual SAP system servers. Those are the components who gather the data that you need for your systems monitoring and enable you to query these collected data. Then Grafana you can use to query this data and put in nice dashboards for visibility, to be able to drill down into problems, as we will see later. And then on the other side, the alert manager, which is actually part of Prometheus, allows you to get notified when things get out of control, when things happen that you want to be informed about. So this is the very high level architecture of a monitoring system. And let's go deeper into the exporters. As I mentioned, these do the data collection.
Yeah, this is an example how should an exporter could look like. You can see on the right side in the picture, you could have multiple collectors which are connected to multiple processes, and the exporter is afterwards able to expose all the matrices at once. Or the original design was to have a very thin exporter specialized for a specific process. So if one exporter with one collector connecting to one process and exposing those informations via the HTTP port. Yeah, the major intention was to have very thin, highly specialized exporters to gather the information from the system. Yeah. With our products, with SUSE Linux Enterprise Server, SUSE Linux Enterprise Server for SAP application, and SUSE Manager, we ship different flavors or different kind of exporters. For the SUSE Linux Enterprise Server, we have exporters which expose operating system and hardware-related information. Therefore, we have the node exporter and collectd. And with SUSE Linux Enterprise Server for SAP application, we have in addition an exporter which is able to expose cluster matrices. We have the HANA database exporter for the HANA database, and the SAP host exporter for the application for the SAP application server stack. And new with SLES 15 SP5, you will have the PCM, the processor counter monitor. Performance counter monitor, sorry. I do this all the time wrong. On the SUSE Manager side, we have, in addition to the node export and collectd, which we already know from SUSE Linux Enterprise Server, the GXM exporter, which is a Java exporter. We have the Postgres exporter for the database and the Apache exporter. Those exporters are more or less there for self-monitoring of the SUSE Manager himself. And in addition to that, we have the exporter proxy and the black box exporter. And I will come in a bit more detail later on. There are additional exporters available. If you check out the OpenSUSE repositories or the package hub, you will find some more exporters, but the exporters which we ship with the products, they are fully supported and fully maintained, and the exporters from the OpenSUSE and the package hub repository have no L3 level support, so to say. So no SLA. That's what I would like to say. Okay. A little bit more in detail for SAP workloads, we have this Prometheus HANA database exporter. With this exporter, we are able to export SAP HANA database matrices like internal alerts, replication details, memory consumers, hardware-related statistics for network and network usage and storage. And the exporter is able to export matrices for more than one database or tenant per host, or it's possible to run one exporter per database. For the dialog instances or for the application server, we have the SAP host exporter. This exporter is a stateless HTTP endpoint, and on each HTTP request coming from the Prometheus server, it pulls runtime data from the SAP system via the SAP control web interface. And there we expose data including service processes, the enqueue server stats, and disk and work process queue stats. The cluster exporter. The cluster exporter inspects the cluster status and exposes them as metrics. So we will get metrics about pacemaker cluster summary, nodes and resource stats, chorus and ring errors, quorum votes, SPD device health status, and also DRBD resources and connection states. The PCM, Performance Counter Monitor, is available since LES15 SP5, as I already mentioned. The PCM sensor server here is a collector who's exposing Intel processor metrics over HTTP in a JSON or Prometheus format. This tool provides detailed information about CPU cache statistics, CPU interconnect communications, and other CPU and CPU memory load situations. collectD, to be honest, is becoming my personal favorite more and more. collectD is a daemon which collects system and application performance metrics periodically and provides a mechanism to store the values in different ways. collectD gathers metric from various sources like the operating system, applications, log files, and external devices, and can either store this information or make it available over the network. And this makes collectD very, very flexible. The node exporter, which is the basic part for all our products. The Prometheus exporter is made for hardware and OS metrics in the majority of this exporter. And similar collectD, it's a pluggable metrics collector, and the default collection can be modified and extended depending on the needs. And the same is for collectD. So on the next slide, we have this black box exporter. The black box exporter is allowing black box probing for endpoints over HTTP, HTTPS, DNS, TCP, ICMP, and gRCP. This is quite helpful to check availability of expire dates for certificates or the encryption support for web servers or remote management boards. The next bunch of exporters, the GMX exporter, the Postgres exporter, and the Apache exporter. As I already mentioned, those exporters provide more or less insights from Zuma, or is for self-monitoring of the Zuma server. And those exporters provides insight of the Zuma processes like web server queue, Java engine workload, resource consumption, and other database operations. The exporter sounds funny, is a simple reverse proxy for Prometheus exporters. And this exporter simplify firewall administration by summarize multiple running exporters and expose them via a proxy port. So putting it all together means how can we install or how can we get access to those exporters? We have multiple ways. We can use YAST, the graphical installation tool, or you can use Zipper. With Zipper, you can search for, as mentioned in the example, type Zipper search exporters, and then you will find the available exporters in your products. And with Zipper install and the exporter name, you can simply install the exporter. If you would like to have more centralized deployment and controlled installation, we see it on the next slide. You can use the Zoomer server. And with the Zoomer, we have salt statements, salt formulas, where you can select the exporter which you would like to deploy and the system, and you can manage and control and install and patching all the exporters with the Zoomer server as well.
Okay. So next we want to show you a small demo. We prepared a short scenario where we want to show you some troubleshooting on a Grafana dashboard. Give me a moment. Okay. So first of all, let's assume that some sub-user are complaining that the access to the system sometimes stucks and freeze for a few seconds. They give us a time frame from 10 a.m. until 1 p.m. on the 1st of June. Let's also assume that we already found out that the problem is not on the sub-application server, but on the database side. We have two HANAs with system replication, so we have a primary and a secondary one. In this first dashboard, we want to look is the OS dashboard, and this is all the data came from the Prometheus node exporter, and we have the typically CPU, memory, network, disk usage, and so on. Let's first of all take a look at CPUs. And in this section, we see that there is a increasing of I/O weights. At that time, they reported the problems. Then let's go to the next one, the memory usage. This is a normal memory usage, let's say. The next one would be the network part. Here we see nothing special. Everything seems to be more or less okay. This, yeah, there are no spikes, so that is too much. Yeah. And then we go to the disk, and in the disk section, we see at the time the problems reported, it is relatively normal, but later on at around 4 o'clock in the afternoon, we see an increasing of the HANA log mount point, and this is constantly increasing. So let's keep that in mind. It is, as I said, later on, and not at the time the problem appears, but we come to that later. Next, what we can do is we go to the SAP HANA dashboard, and this dashboard is using data from the HANA database itself via the Prometheus HANA DB exporter. This is this one. And if we click on the system replication, we see that everything here is red. It means that the system replication is not working, and it's still not working. If we then go to more details in the internal alerts, we also see that there are a lot of high alerts by the HANA itself. And the details say here that the communication channel closed, and under user action, you can read investigate why connections are closed, for example, network problems. So we already looked at the network on the primary side. Let's take a look on the secondary side on the networks. For this, we go back to the OS dashboard and we change the host name. This is then the host name ls3331. And if we then go here to network and go down to the interface link, we see here in orange that the ETH1 has some problems. We see if we zoom here in, we see here a lot of up and down of the link. So the link is up and down and up and down. And give me a moment. This, okay, let's go back. Yeah, here. After several time, about 3 o'clock, the link is completely down. And to summarize this, we saw at the time where the problem happened an increase of I/O weight, and now we can see on the secondary node that the network was flickering, and after a certain time it is completely down. In our scenarios, the admin discussed this with a HANA expert, and he learned that once the system replication stopped, the primary is also freezing for around 30 seconds or so. And this means there's a directly dependency between the replication and the accessibility of the whole HANA database. And this would explain that the whole subsystem was stuck and freezing for several seconds. Yeah, this is our demo, and Bernd will tell us some more about that.
The scenario which happened at the customer wasn't covered by some alerting rules, and therefore they have improved the situation or have improved the monitoring situation. Let me start with the second part. First of all, they have created a special alert rule for the system application network. So they look for devices which they have excluded devices, which are not the local one, 8H2 and 8H3. So just to cover the interface which is responsible for the HANA system application network, and just use this rule for special hosts which are involved. In those cases, it's ls, as mentioned there, the two nodes, 29 and 31. And they look for the network interface status, if it's up or not. And if it's not up, they will get an warning. This is the first improvement. And the second one, they have used collectd with an script. So in collectd has the opportunity to run a small script and create a new matrix based on this. And we can capture the status of the log segment files. Looking in the log segment files or using HDB log diag, this tool is coming with SAP HANA, we can check the status of the log files. And if a log file is already backed up and just waiting for shipping on the secondary side, it gets the status retained free. What we can do now with a script is look in the log files and count how many files have the flag retained free. And checking those files generates with collectd a matrix. And then we can, if you go back, Thomas, one slide back, we can generate an alert with this, which say average over time, the new matrix, which we have created with collectd, with the flag retained free, and say if we have more than 2 files in 1 hour, which this flag something might go wrong. And this could help us to avoid the situation what we have seen in the demo with the increasing file system, because if we check the flag for those file systems, we would get informed very, very early before we could see such an increase of the occupied file system. Okay. As a summary, Prometheus and the exporters with the functionality of collecting data, storing data offline of the system, we could avoid situations by could avoid downtimes by using those data and do a prediction on those, calculating or estimating situations which would happen like file system full or other strange situation like network latency is increasing and other stuff. So the first goodness of the monitoring could be prevent situations by capturing unusual behavior of a system quite early. Next thing is if something happen, to get notified that something happened, systems crashing, services not available, a certificate is not longer valid and is expired, and so on. So getting notified quite early is helping to reduce downtime and inform the right people in the first place. And yeah, when something happens, the possibility to have the data available untouched from the system. So we are totally independent with the Prometheus data collection, which is a dedicated server, or should be a dedicated server. You can do the analysis of the situation with the stored historical data, totally independent from the system which is involved in the outage, gives a great benefit. And as we have seen in the example, a situation could happen. You can add or improve your monitoring solution by adding more rules, especially for the situation, to get informed earlier next time. Okay, thank you for your time. I guess that's all from our side. Here we have collected some links for you to look into or to look onto. The documentation on the SUSE side and also some blog posts which we have written. And I can promise there will become more blog posts, small pieces to get more insights or to more examples what you can do with the exporters in advance. Thank you.